Alright, so we're going to do some limiting reactant problems. So take the reaction NH3 plus O2 goes to NO plus H2O. In an experiment, 3.25 grams of ammonia are allowed to react with 3.5 grams of oxygen, and they're telling us to find ABC. So the first thing you always want to do is we want to start by finding the balanced chemical equation. So we're given this equation. We are given that NH3 ammonia plus molecular oxygen goes to NO plus water. So right now we have 3 oxygens on this side and 2 on this side. So let's try to get those together. So we're going to multiply this one by 2 and this one by 3. And we will get, now we have two nitrogens on this side, and we have 1 nitrogen on this side. So what we're going to do to fix that is we're going to add a 2 there. So now we have 2 nitrogens on this side, 2 nitrogens on this side, 6 hydrogens on this side, 6 hydrogens on this side, and we have 2 oxygens on this side, 3 oxygens here, 2 oxygens there. So we have 5 oxygens on this side. So we have to balance this out. So in order to get, we have 5 oxygens here and we have 2 here. So in order to get to 5, we need to multiply this side by 2.5. So we're going to multiply that by 2.5. But because we don't like to deal with decimals, we're going to multiply each of these by 2 to get them to whole numbers. So we're going to multiply both sides by 2. And let's get rid of that. So times 2. So what we end up with is something that looks like this. So let me write this out again. So we have NH3 plus O2 goes to NO plus H2O. So when we multiply 2 by 2, we get 4. When we multiply 2.5 by 2, we get 5. And when we multiply 2 by 2, we get 4 again. And multiply 3 by 2, we get 6. So our final balanced equation is going to look like this. It's going to look like 4 moles of ammonia, 5 moles molecular oxygen, 4 moles of NO, and 6 moles of water. Now that we have a balanced chemical equation, we can go on to convert our givens into moles. So we are given that 3.25 grams of ammonia and 3.5 grams of oxygen react together. So let's start by converting the ammonia. So we have 3.25 grams of NH3. Let's put that over 1. And that's we want to get it to moles. So we're going to do 1 mole of NH3 is equal to, over here we have, on this side of the page, I already did it beforehand. So we have 1 mole of nitrogen is equal to 14.01 grams. And we have 3 hydrogens in the NH3. So we're going to get 3 times 1.01 because the molar mass of hydrogen is 1.01. And we have 3 of them. So you would do 3 times 1.01 and you get 17.04. You could find these numbers on your equation sheet. So we have hydrogen up here and we have nitrogen right here. So continuing, we're going to do 17.04 grams of NH3. So our units will cancel out, and we're going to be left with 3.2. We're going to be left with moles of NH3, and we can put in the calculator 3.25 divided by 17.04, and we'll get that equals to 0.191 moles of NH3. Now for oxygen, we'll do the same thing. So we start off with 3.5 grams of O2. We're going to put that over 1, and we're going to 1 mole of molecular oxygen is equal to. So this is the part where a lot of people make a mistake, because they say, oh, okay, well, we have oxygen here, so we need to figure out the molar mass. And they'll come up here and they'll see, okay, well, there's 16 grams per mole. And although that's true, we're talking about molecular oxygen and not just atomic oxygen. So we're going to have 2 oxygens here. So we're going to have to multiply 16 by 2, which is going to give us 32. So we're going to have 32 grams of oxygen. Our units cancel out again, and we are left with 3.5 over 32, and that's going to give us 0.109 moles of oxygen. All right, so now that we did that, we're able to find the limiting reactant now. So the way I like to do it is we have our moles of oxygen, O2, over our moles of ammonia. In this case, it's these two. And this is going to be our required, and I'll get to that in a second. And then we'll have our moles of O2 over moles of ammonia. And this is going to be our actual. So our required is what is given to us in our balanced equation. So we're required to have 5 moles of oxygen, molecular oxygen, and 4 moles of ammonia. So we'll put that as 5 over 4, and we get 1.25. So our ratio will be equivalent to 1.25 here. So for this one, our actual is going to be what we got here, how much we have from the grams that we were given, which is going to be 0.109 over 0.191, and that's going to give us 0.57. So because our actual is less than our required, which of 1.25, we can conclude that our limiting reactant is oxygen, molecular oxygen. And if you wanted to check it again with the other way around, we could just do it over here. So we'll get 4 over 5. All we're doing here is just switching the numerator and denominator. So molecular, or the moles of ammonia are in the numerator, and the moles of oxygen are in the denominator. We're doing it for this side and this side. So we get 4 over 5, which is equal to 0.8, and we'll get 0.191 over 0.109, and we will get, putting that into the calculator, we get 1.75. So that means our actual is higher than what we actually need, which tells us that we have more ammonia than what we actually need for this experiment, which furthermore, that just means that oxygen is our limiting reactant. So we can go ahead and come up here and write that. So Which is the limiting reactant? It's oxygen. And then to be more specific, so the graders don't take any points, you can write in parentheses O2. So now we are asked how many grams of NO are formed. And to do that, we have to use the limiting reactant because that's what's going to run out first. So since our limiting reactant is oxygen, we'll use the moles of oxygen, which is 0.109. So we'll take that down here. I'm going to just bridge this off so you know that we're starting something else. So 0.109 moles of oxygen. And we'll put that over 1. And now we need to get this into moles of NO before we get it into grams of NO. So we need to look at the mole ratio. So here, 5 moles of oxygen reacts to form 4 moles of NO. So that's going to be our molar ratio. So we're going to have 5 moles of O2 and 4 moles of NO. So our units are going to cancel out again. So we're left with 0.109 times 4 divided by 5. And we will get, after plugging that into the calculator, we get 2.62. Oh, sorry, I missed the biggest step. So now that's going to give, what this will give us is our moles of NO. So what they're asking for is the mass in grams of NO. So for that, we're going to have to multiply this by the mass. So we know 1 mole of NO is equal to 30.01 grams of NO, which we found that just by coming to our periodic table, and oxygen is 16 and nitrogen is 14.01. So 16 plus 14 is 30, and then adding that 0.01 is going to be 30.01. So that's where we got that from. So now we can do 0.109 times 4 divided by 5 times 30.01. And notice how our units also cancel out here. So doing this in the calculator, we'll get 2.62 grams of NO. So we can go ahead and write that up here in the answer. So 2.62 grams of NO. And then if you want to go in complete sentences, you can are formed. And then lastly, we're asked how much of the excess reactant remains after the reaction. So to find that out, we just need to figure out how many moles of NH3. Since NH3 is our excess reactant, we need to find out how many moles of NH3 are used in this reaction. So we need to start off with 0.109 moles of oxygen. Put that over 1 because this is our limiting reactant. We want to figure out how much moles of NH3 is used before when this is used up all the way. So we're going to multiply this by our 4 moles of NH3, and we're going to divide it by our 5 moles of O2. And if you're wondering where I got those numbers, I'm just looking back at the balanced chemical equation. So we know that 5 moles of molecular oxygen is going to react with 4 moles of NH3 to have a proper reaction. So doing that in the calculator, we'll get 0.087 moles of NH3. And this is not our answer. So what this tells us is what amount of NH3 was used up. And what they're asking for is what's the excess amount. So we have to start with our total, which we had right here. We calculated earlier 0.19 moles of NH3 is our total. So 0.191 moles of ammonia minus that what we calculated here, which was used up. So 0.087 moles of ammonia. And that's going to equal 0.104 moles of ammonia. And then you can just put in parentheses left over. So then we can go ahead and write that here. So it was 0.104 moles of ammonia left over. Alright, now this video is getting kind of long, so I don't want to keep you anymore.